So today we're going to go through and we're going to take a look at the Unit 1, Day 5, which is Equations of Lines and Coordinate Planes Notes. So hopefully the stuff that we're going to be doing here today is maybe a little bit more of a review, something that you've seen before in algebra. And we'll see kind of how we take that to the next level here in geometry. So first, let's talk about things that we might already know. So the slope. If I'm looking at the slope of a line, it's the number determined by any 2 points on the line. This number describes how steep the line is. The greater the absolute value of the slope, the steeper the line is going to be. So if we have a line that has a slope of 2, it is not going to be as steep as a line that has a slope of 5. So when we talk about slope, and I know we have a nice picture over here, and you're going to see I may make a little bit of error, so I apologize if I do that. My equation of slope in general is going to be using this formula, right? So we end up using m equals y2 minus y1 over x2 minus x1. So especially once we get started looking at coordinates, we're going to be able to determine what our x1, y1, x2, and y2 are, and that's going to let us determine what the slope of that line is going to be. If we take a look at the example that we have over here, we gave you an equation of a line with a picture of a line, with 2 points. And when we count this, we could go through and we could actually use the formula that we just came up with. Or if you have a picture, you can always look at the rise over the run. So in this case, we're going up 1, 2, 3 boxes. We're going over 6. So when we determine the slope of this line, we're going to say that our slope is equal to, well, we rise 3 and we run 6. So it would be 3 over 6. Now, we don't want to leave it like that, though. We want to make sure that we reduce that fraction. So 3 over 6 reduces to 1 over 2. So I'm going to write that up here as well, just that we have our rise over our run, because that's a good way to remember how to find slope. So we have 4 different types of slopes that we look at. First one is going to be a positive slope, which means for that line, right, when we rise, we're going up. And when we run, we're going to the right. So positive slope, sometimes I think about it like a mountain. It's like I'm going up the mountain. So this would be an example of a positive slope. A negative slope is the opposite. If you notice, as we go down, we go to the right. So going down, that's what makes it negative. Going to the right is positive. If we have a negative over a positive, that is a negative slope. Same if we look at it the other way. If I go up and to the left, up is positive, left is negative. So overall, that would make that slope a negative. A zero slope. So a zero slope is going to look like this. And we might see it, especially if we start getting into points. That's going to be a situation where our rise over run is going to be 0 over a number. If you type that into your calculator, like 0 divided by 3, you'll notice that it'll just give you an answer of 0. That means we have no rise in our slope. All we're doing is moving right and left. And as we go on, you'll notice our equation of a line for a zero slope is going to look like a y equals a number, which is saying every single place in that line, the y value is going to be the same. But we'll get to that a little bit further on. Last one we have is an undefined slope, which is going to look like a straight up and down line. That's where we have a number on top and we get a 0 on the bottom. If you try to type that into your calculator, any number divided by 0, it'll give you a divide by 0 error. It won't do that because we can't divide by 0. So your slope here is undefined. Notice we're only rising or falling, right? We're not moving left or right any, which is why we have our rise as a number and 0 for our run. And similar to our zero slope, remember we said the equation of the line can be y equals a number. This one could be x equals a number. And we'll see a couple examples of that as we start graphing. All right. So first thing that we're doing, we're saying that we want to find a slope of a line that passes through these points. So starting with this first one, I'm going to go ahead and I'm going to label my x1, y1, x2, y2. Technically, you could name either of those points, x1, y1. I always do the first one as x1, y1, I do the second one as x2, y2. I'm a person who likes to do habit, or a creature of habit. I like to do the same thing over and over again. So I just always label the first one as x1. So when I go to find the slope of that line, we said our slope formula was y2 minus y1 over x2 minus x1. We've already labeled all this stuff down. So y2 is 4 minus y1 is 2 over x2 is 3 minus, and I'm going to put this in parentheses because it's a negative, that negative 1. Now I can go ahead and clean this up a little bit. 4 minus 2 is 2. 3 minus negative 1 is going to give you 4. So I got 2 over 4, but remember we want to simplify that down into 1/2. Same with the next one. Even though we have these decimals, right? I'm going to start by labeling x1, y1, x2, and y2. Doing the same thing as before, since I'm finding slope, it's y2 minus y1 over x2 minus x1. And I'm going to start plugging in my numbers. So my x2, or excuse me, my y2 is 1.2 minus y1 is 1.1 over x2 is negative 1.2 minus 0.5 or 0.5. Again, we can clean up the top and the bottom just by combining our terms. So we get 0.1 or 0.1 on top over negative 1.7. When I ended up turning that into a decimal, this one was a little bit weird. I actually just multiplied my whole fraction by 10. And the reason I did that, or just moved the decimal place over, is so that I got rid of that decimal. So I've got 1 over negative 17. And that was my slope for that one. For C, same thing. We're going through, we're labeling our x1, y1, x2, y2. So we've got our slope is y2 minus y1 over x2 minus x1. I always write the formula over and over again, just so I get in the habit of remembering it. I've got 1 minus 1 over negative 1 minus negative 3. And if you notice on this one, 1 minus 1 is 0. On the bottom, 1 minus negative 3 is going to give me 2. I have 0 over 2. 0 over 2 is just 0. So the slope for this one is just going to be 0. Remember, that's a line that's going to end up looking just like that. It's going to be all horizontal. Last one, we've got x1, y1, x2, y2. Notice that's why I like to do the same thing every single time. It's a little repetitive, but it also helps me learn it and make sure that I really know it well. So I always rewrite it. Got my y2 is 5 minus y1 is negative 5 over 2 minus 2. When I simplify it, I end up getting 10 over 0, which means I'm going to end up with an undefined slope. And that would be a line that looks like that. So there would be my undefined slope. One thing to note, I always like to think of my undefined and my zeros, right? If I'm an undefined slope, notice my x value is always the same in any point that I use. For my zero slope, my y value is always the same. Just a little thing to look for. All right. Going a little bit further to the right, we have this triangle over here, and we want to be able to find the slope of that triangle, or of each part of that triangle, excuse me. So the first one here, we have AB. So I'm actually going to start from B, and that's okay that I do that. I can go from A to B or B to A. You're still going to get the same thing. I always start with my rise first, so I'm just going to count boxes. I rise 2, 1, 2, 3, 4, 5, 6. I run 6. So when I write my slope, remember it's rise. I said it and then I started writing the wrong one. I rise 2, I run 6, but we want to change that answer to make sure that it is reduced. So we get 1 over 3. Same thing for AC. All right, I'm going to try to use red, mix up the colors a little bit. I'm going up 1, 2, 3, 4, 5, 6. Running 1, 2. Oh, this one's kind of the opposite of the one we just did, right? This one is 6 over 2, which is the same thing as 3, or 3 over 1. Now, I know I just circled 3. I like to think about it as 3 over 1, just because it reminds me that I have some rise and I have some run. So sometimes I like to write that as the fraction just so I remember that. And last but not least, from B to C, right? I'm going down 1, 2, 3, 4. If I go down, that is a negative. So negative 4 over 1, 2, 3, 4. My rise of a run is negative 4 over 4, which actually reduces down to negative 1 or negative 1 over 1. So if you have the picture, you can go ahead and you can just count your boxes a little bit to get your rise and run. If you're somebody who likes using the points, you can do that as well. So the last thing I'm going to do in this video is I'm going to help us with this last problem. I want to split the video up into two just in case you only need help on the first side or you only need help on the second side. So we are finding the value of r so that the line that passes through the following pair of points has the given slope. So essentially we are finding our r value here. So they give us our slope, which is a little bit different than what we've normally done, but we are in the habit of writing our formula over and over again. So I'm going to start that same way. We said my m equals y2 minus y1 over x2 minus x1. And I'm going to label my points just like I've been doing. x1, y1, x2, y2. I'm going to go ahead and I'm going to plug in the values that I know. My y2 is 5 minus my y1 is 3. My x2, that's what we're trying to solve for. That's r. So I'm going to put that right down there, minus negative 4. That's my x value. Last but not least, we actually know what that m value is. That's 1 over 4. So since we knew what that was, now we have all the pieces of information that we need so that we can solve for r. First thing I'm going to do is I'm going to clean up this highlighted piece in yellow, and then I'm going to clean up that highlighted piece there in green. I'm not changing that 1/4 at all, but 5 minus 3 gives me 2. R minus negative 4, I'm just going to rewrite that as r plus 4 for right now. Now that we have this 1/4 equals 2 over r plus 4, I'm going to use some knowledge of proportions. And if you're unfamiliar with that, that's okay. We're going to talk about that later in the semester. I'm going to cross multiply here to help solve. So I've got 2 times 4. That's going to give me 8 equals 1 times r plus 4. Running out of room. I'm going to distribute it and end up getting that 8 equals r plus 4. Last thing, to get r by itself, I'm going to subtract 4 from both sides and get that my r value equals 4. So if I plugged in 4 as my x2, I should end up getting 1 over 4 as my slope. So again, I'm going to pause the video right here and start another one in a second for the back side of the notes, but this is the first side of the notes that we have.